Today I wanted to do an updated video on how I use Blender as my video editor in Linux. Now, most people think of Blender as a 3D modeling program, which it certainly is, but it also has a VSE in it. If you want to, you can use this VSE as a video editor. It takes all the regular types of things, videos, images, sound, and you can just edit videos with nothing but Blender. So, first off, let me start with some background information before I go into how I use Blender as my video editor. Now, I have all of my video assets stored on my server, and I have my desktop connected directly to my server exclusively on its own gigabit network connection. So what this means is I have high-speed access to the video files over the network. I never have to store the video files on my desktop. Now, this is important because most of my workflow is built around that, but a lot of this can be adapted to a single computer usage as well. So another reason that I like Blender is that I've been able to write many of my own add-ons to make Blender work better for me. So as I show you how I use Blender, I'm going to demonstrate those add-ons and what they do. Another thing I like to do for my video projects is use a skeleton directory that contains all of the basic files I need for doing videos. So I have one folder that I constantly work on and make changes to, and that's how I set what my video project directory structure looks like. So today I'm just going to make a fake video, and I'm just going to make a copy of that, and we'll just call it test. And from there, we'll edit a video using those files. So we're just going to start out by putting these video files into the Assets Video 1 folder. Now this folder represents the first channel on the VSE, and I have an import script that will automatically find these video files and import them. So once these files have finished copying in, I'll show you how the import procedure works. Okay, now that we have all the video files copied in, I'm going to go over to my server here. I'm going to run the import script embedded in the Blender project. And while that's going, let's take a look at what that import script is. So first of all, let's look back at a finished project. Blender has a feature called Proxy files for the video files. So if I let this play, you'll see here that it's running at about 60 frames per second because that's what the video frame rate is. However, if I disable the proxy files and just use the regular video file, which is 1080p at 60 frames per second, and try and run that, you'll see that it is significantly slower. So what you can set Blender to do is on each video file, set it to generate a video proxy that is a certain percentage of the full video size. So what I do is when I import the video assets, I have it automatically generate a proxy for each video clip. So what this script does is it goes through the directory where all of the video files are, it finds the different numbers in that video directory and imports those as the channel ID, and then it adds those files to the VSE one after another. So they're already sequentially added, meaning I don't have to manually import each file. Then after they're all added to the VSE, it automatically creates the proxies for this. Now I do this on my server because the server's CPU is much faster at this than my desktop's. Then once the video proxies are generated, I generate audio proxies, which gets us to my first add-on here. So because I edit all of my video projects over a network, I have to have everything be streamable quickly. Now, my camera records audio as PCM audio, meaning it's uncompressed, so it's very large and high bitrate. That doesn't stream particularly well. So what I did is write an add-on that can generate audio proxies at a lower bitrate to make editing easier. But then when you go to render, you go back and use the original full resolution audio clips. So what this does is after it has added all of the strips to the sequencer, it goes through and creates audio proxies for all of the audio clips, and then it sets them all to use the proxy because you can switch back and forth between the proxy files and the original files at will with my add-on. Then once the import procedure is done, it saves the file and it's ready to use. And here we can see in the back, it's now rendering the audio proxies. So you have to use FFmpeg as a separate Python module. So far as I'm aware, you cannot access Blender's internal version of FFmpeg, unfortunately. Alright, now that the import procedure has finished, let's go ahead and open our project. So now that it's open, I can see that the video files and associated audio files have already been imported. And if I just select one, we can see that this loads pretty quickly. And if I play it back, it's running at 60 frames per second. So, perfect. Now, if I select one of these audio clips, we can see that it's .mov.ogg because the default setting for my audio proxy plugin is to use OGGs. Now, you can go and configure that by changing the add-on preferences here to a different file extension. Also, I assume you're using a project proxy directory, and I automatically put the proxy files into a separate audio subfolder of that proxy directory. Now, once we're in here, I by default have waveform drawing disabled in case I'm on a slow computer, but I can re-enable that. Now, this was a failed video concept, so this didn't turn out that well. The audio is terrible, and it was a kind of boring video to begin with. So, now that we have some files in here, we need to start editing. So first off, on the VSC, I have another plugin here, VSC Controls. Now, all that plugin does is add the controls from the timeline view. So if we go to the timeline view, you can see at the bottom here, we have these controls. Now, these don't normally show up in the VSC. You'd have to have the separate timeline window open. Now, once we're in the VSC, we can start working with our clips. So let's just start off with some basic things. You can right-click, like Blender usually does, to select things. Hold Shift to select multiple things. You can press G to move them. Hold Shift to move them slowly. And left-click to place. Now, another thing you'll want to do with your strips is cut them. Now, there are two kinds of cuts in Blender, soft and hard cuts. So let's move the playhead to the middle of our files and just press K to perform a soft cut. Now, a soft cut just marks a position as a start and end and duplicates the strip. So what that means is I can change the start position to recut my existing files. Now, if I want to make a cut permanent, I do Shift-K, which takes a little more effort, and that is unchangeable. So now if I move these here again and try and drag this back, you'll see that there's no data in that strip. Typically, you just want to use soft cuts. Now let's say you want to add some text to your video. You can go to Add, Effect Strip, Text, and then in the Effect Strip area over here, you can change what the text says. You can add in some words. And then you can change the size. Now, I found this to be unreliable, the preview here. I've had it be longer than it shows up here. So this isn't the best way of adding text to your video. A better way is to go ahead and render a specific frame by clicking the render button here. Then go to the UV image editor, view the render result. And then while you're in this window with your mouse cursor, hit F3 to save the rendered image. We'll go ahead and put that into images. And I'm just going to leave it as untitled. Then from here, we're going to go back to the asset directory. Open that image with GIMP. And then we'll use this as a frame of reference to add a text strip wherever we want. So say we wanted some text like that. So now we have a separate layer. We'll go ahead and just hide the render layer and then re-export as a PNG. And then once that's done, we'll go back to Blender, set this back to the file browser. And now we have a PNG that we'll just go ahead and drag, and the image, any new assets you add from the file browser are added at the playhead position. Now once we have the image in here, we're just going to go ahead and set it to alpha over, and there we go. So this will allow you to use different fonts or add other effects or layer multiple images. Blender doesn't like adding images with just a position into the scene. It wants to stretch any image you put in there to the full size of the render display. So say you put in a 640 by 480 image it would stretch it to 1920 by 1080. So you're going to have to create images that have transparencies in a frame to have it be the original aspect ratio in here. There are ways where you can do image offsets and crops, and then you can add an effect strip to transform your image, but it's just not worth the trouble, because you have to go through and then you have to try and do scaling, and it's a pain. It's not worth it. So just go ahead and make your images with a transparent background that gets directly overlaid. It's much easier. Okay, next let's cover something that's really annoying to do in Blender, and that is speeding up video. So let's say we have this part here where I drill out a hole in these headphones. So we want to speed up this particular portion of the clip. Let's say from here, I'm going to place a marker to, yeah, right there, sure. So we're going to speed up between these 2 points. Okay, now, to speed up this segment, we're going to have to create a hard cut video segment, because the speed control doesn't work well with soft cut segments. So what I would recommend doing is, before the area where you want to do a hard cut, do a soft cut on both ends, and then go to the area that you actually want to perform your hard cut, and then do it there. This way you don't do a hard cut at the end of the strip before and after the segment that you want to do your hard cut. And we'll go ahead. You do have to select the strips that you want to perform your cut on. There we go. And now we can select the video file. We're going to add effect, speed control. And from the speed control, we'll then want to, it by default wants to set the video to just last however many frames you have. So if we want to set it to something explicit, like 10 times speed, we're going to disable the stretch input length, set the speed factor to 1, and set the multiply speed to 10. Now this section of the video will play back 10 times faster than it normally would. It can take a while for Blender to catch back up with the hard cuts for the proxy files. It's not the smoothest thing. Hard cuts kind of suck. Now, this does the video strip, and if we get farther ahead, we'll see that that video strip is now repeating the last frame because it's playing back 10 times faster. So what you need to do is go to the length at the top here, and then what we're going to do is divide. You can just do math directly into the fields in Blender, and we're going to divide by how much we multiplied by, and that will set the length of the strip to the exact number of frames we need for that sped up segment. Now for audio, we need to do something similar, but we don't have to add a speed control. We just change pitch if we want to use high frequency audio where we just change how it sounds. It's usually how I do it. So we're going to set the pitch to 10, which will make it play it back 10 times faster. And we're going to do the same thing here. Divide by 10. And now we have a fully sped up segment. This works very easily. So, that is speeding up, and I think that covers most of what you'll need to do in Blender. You might want to have fancy frame transitions, which you can do by setting keyframes. So say we came over here and we set the opacity to 1. Here you hover over something, press I, and then go to the end of the frame, set the opacity to 0, and then press I to set that keyframe. As it plays, you will see that the video will start to slowly fade out. And then what you could do is have this on a separate strip below it. So if we put this one more channel up, had this underneath, and played through that, you would see the other strips start to come through beneath. So that's, yeah, Blender's really easy to use. So, you know, it's just one of those things where you should play around with it if you're really wanting to learn how to use it. All right, now let's pretend our video editing is done. So we're going to need to set the end of our video as a frame point here. So I'm just going to set my video to be 30 seconds long-ish, and I'm going to copy this frame. This is the current frame that your playhead is on. And I'm just going to copy that position and mark that as the end. And you can see how this point now jumped into here, and you can't move the playhead outside of the animation area. So now that we're done, we're just going to have this 30 seconds. I'm going to save this. And now we're moving on to my next plugin, which is Subprocess Rendering. Blender is technically multi-threaded, and if we look at, I think, performance, we can see here the number of threads we have. It's set to auto-detect. This is a quad-core computer, and it has no hyper-threading, so we have 4 threads. While a Blender is multi-threaded, it is not multi-threaded in a way that is optimal for video rendering. Blender is designed as a 3D model renderer. So what that means is Blender is going to render sub-images of the 3D scene and then stitch them together. So it uses multiple cores to render segments of the 3D image. Now, if we go to default and I have the render result open here, and I change this to show the compositor and then render a frame, so you can see how it brings us in, and there's only 4 orange squares running at a time because we're using 4 threads. So Blender's going to do the same thing for rendering your videos. It's going to segment out each individual frame and render portions of that frame with separate threads. Now, each frame is very simple because it's one image, so it's really quick for Blender to render an individual frame, and it really doesn't help that it's multi-threaded. So to work around how Blender normally renders frames, I created a plugin that will run multiple instances of Blender at the same time and have each instance only render one set of frames from your project. Now, you should probably set this to fixed number of frames 1 here, but I typically just leave it on auto detect and it's not that big of a deal. You can choke out your disk access with too many threads trying to access the files, so play around with that to see how well it works for you. Now, when you're using this plugin, you can set it to use all of your threads, only this number of threads. So if I wanted to use half the threads on my desktop, I could set it to 2, or I could do except. Now, this means it will use all threads minus this number, so it's going to use 4 except for 1, and that's useful if, say, you want to make sure you have this many threads free for other tasks on your system. You could do the same thing with only, but doing it this way allows me to render on my desktop or my server and have just, say, 1 thread always free. Now, you'll have a second output path here because you need to set Blender to render frames, images. So you're going to set it to JPEG, and 80% works better than 90%. I haven't noticed a drop in image quality, and it's nearly 10 times less disk space used, so it's really worth the drop in image quality just for that, because it's going to render every single frame as a separate JPEG when you do this, and then it's going to render the audio as a separate FLAC, and then recombine them using these FFmpeg settings here, and it's going to default to these, which are optimized for YouTube, and if you ever change that and you need to reset it, you can just right-click and then reset to default value. Now from here, you would click Start Render, and we can just go ahead and do that. So I'm going to open HTOP here, which shows the CPU utilization per thread, and I'm just going to run this on all threads, and we can see that OBS, which I'm using to record, is maxing it out, and here we go. So we can see we have 4 separate instances of Blender, each set to render a different start and end frame, and this is now going to be better utilizing the CPU with these separate instances. Now, while that's going, it is creating a folder in the projects editing directory that has all of the frames in it. And then at the end, it will render the audio files as well. And then it will use FFmpeg again to recombine everything into one AVI for upload. So how many frames do we have? We have 1,800 frames. We can see how many we have going here. Now what I normally do when I'm running this is, again, I'm running everything on my server. So I would normally, Blender locks up when you run a long operation. So I have another script embedded in here that will just start the subprocess render. Then I could just run an export command the same as I ran the import command over here, and it will do the subprocess rendering. And then it will do something else afterwards, which is the next plugin I have. So I use Blender for creating YouTube videos, and I wanted a way of natively uploading YouTube videos from the command line, so after a video finishes rendering, it can just go straight to YouTube's server without me having to interact with it. So I wrote a Blender YouTube upload add-on, and when you're in the video project, you can just set some basic information about the video, whether it's unlisted, private, set the title, set a brief description, because Blender does not have a way of doing multi-line inputs in the panels like this. I could use a text block like the scripts are and then import it from that, but that's inelegant, so for right now, I'm not doing that. Probably in the future I will. Unfortunately, the YouTube upload plugin requires that you generate your own API key for using YouTube as a server client. I can't distribute that with my open source project because you're supposed to keep these secret. If I compiled this to an executable, technically it would be allowed. It's the way the Google terms of service work for the APIs. So once the video is finished rendering, we can see now it has finished rendering. We have all 1800 frames. It created an audio output FLAC, and now it's joining them into one AVI file. Also, once it finishes rendering, it will automatically delete all of the individual frames and the audio file that it created, but there are some limitations to how this works. So just as a precaution, I don't assume people are using a separate subfolder for their frames because you have to explicitly put it here in the normal Blender output. So when I'm deleting the files, because those frames take up a lot of space, I delete them afterwards. When I'm deleting those files, I can only explicitly delete individual frame file names, which causes some problems. In the future, I may assume that this has a separate subfolder and then just delete the folder, which would be a lot cleaner. But now we have our separate AVI file, and if we open that with VLC, we can see that we're good and it works. So, what we can do now is go to the YouTube upload plugin. Now, I have an option here to use the default video render path from Blender, but that doesn't work with the subprocess rendering because this would then be the individual frame names. So, you can't use that. So let's make this video test, and then this is a video. And you can set a thumbnail image to upload as well if you want. So currently this will have none, but we could just set the thumbnail to be one of these. So let's set it to our PNG there. So accept. Then once you set up all that information, you can click Upload Video, and it will start a separate thread in the background and will begin uploading the video to YouTube. And you can hover the mouse cursor over the upload progress to get it to refresh because it doesn't do it automatically. And then once the video is uploaded, it will retrieve the video ID, so you have that, and then it will upload the thumbnail for that video. And we can see that that video is now uploaded. You can see that the raw file is unknown because it's uploaded as a binary stream, so there is no file. Well, I think that's about everything I wanted to say about using Blender as a video editor. The big things that are worth remembering are using the proxy files makes Blender so much faster, especially the video ones. For me, I need the audio proxy ones, but most people probably won't. Some of the other add-ons I have, like the VSC Controls here and Subprocess Rendering, are really helpful. So you may want to look into those. YouTube upload is just going to depend on whether or not you want to upload from Blender. But I hope that was helpful for anyone who has any interest in using Blender as a video editor on Linux. For me, it works extremely well, and it is really fun to use because I write my own add-ons, so it becomes extensible and personalized to exactly how I use it. One feature I would like to look into creating in the future is another version of Subprocess Render that sends out separate render jobs to different computers. Blender used to have a network render system built into it, but it was retired recently. I think there might be a new one in the works, but it's probably not going to be suited for video editing because that's, again, not what Blender is particularly designed for. So I think a Blender add-on that manages rendering jobs being sent to other clients over just SSH really would work, would be really useful. The only real hurdle to get over is that you have to manage how they access the same files. Are they all going to have copies of the files? Do they access them from the same source? If they're accessing them from the same source, that's going to need to be a very high-speed data source. So that it's just a whole complicated thing. So for now, I hope that was enjoyable and educational, and I'll see you guys next time.